Hello, Casa community. It's Chrissy here. Welcome to another episode of Card Maker, where we try to make some cards. So I'm again joined by Luke. Welcome, Luke.
Hey, thanks. Good to be here, Chris.
So we did a Hello World last episode to make essentially like a landing page, an About Me page of Luke and his amazing volleyball, beach volleyball career. And today we're gonna do something a little bit more, financial, more business.
Hey, what do you have in mind?
I think we should make a calculator.
Okay.
Not that type of calculator. There are these class of calculator called like mortgage or financial calculator.
Oh, sure. I've used one of them before.
So it's like something like this. There's a mock-up that I think we should try to make, and it has a lot of data on it. Sometimes data you can enter, and sometimes data you can compute for you. Okay. And I think we want to show that the card system is not just for making like content that looks like PDFs or web pages, but it's actually a fully dynamic application system that can replace a spreadsheet if you're doing it in a kind of desktop productivity, but also like some websites. Have you used those websites?
Oh yeah, absolutely. Back when my wife and I were buying an apartment, we went online and plugged in the numbers to figure out like, can we actually afford this apartment?
Right.
That kind of thing. Yeah.
You go to the website, and then for the next 2 years, your Facebook feed is nothing but real estate stuff, right?
Yes, it's like I guess it's really good lead gen for these companies, right?
Yeah, I don't know, it's lead gen or like little secret cookie that they embed within it. Yeah. So what we were talking about today is a open source solution that we're gonna write, basically a mortgage calculator like this from scratch.
Okay, great.
So why don't you take it away?
Yeah, cool. I've not had the occasion to write one of these in my career so far, Chris, but I think we could probably pull it off. The first thing that I'm curious about is what is the formula that we're, because every calculator has some formulas behind it.
Right, exactly.
So we can look at WikiHow has a little explanation for us here. So the monthly payment, which is like I think the key number we want out of this calculator, is the principal times the rate multiplied by 1 plus the rate up to the nth power, where n is the number of payments.
Right.
So if we're talking about a 30-year mortgage, number of payments is 360 because it's monthly payments. So 30 times 12, 360. Then divided by 1 plus the rate to that same power minus 1. So not super complicated math. Definitely not something I could do in my head, though, or
right.
on a napkin. So I can see why this kind of calculator is useful.
Absolutely. It's not like adding 2 plus 3.
Yeah. So let's start by creating a new card definition. And we do that, of course, in code mode. So I'm going to go over here to code mode and up to our new file button and say, give me a new card definition. We'll call this mortgage calculator. Calculator for the file name as well. Create that. Let's go ahead and add some fields of the inputs that we want to have. So obviously the most important input is how much does this house cost? So we'll call this, let's say home price, and we want this to be a numeric field. So let's go to our base workspace here. Let's see. Well, we have, okay, here's number field. A field that captures number values. Sounds perfect.
Mm-hmm.
So we'll choose that one. Just one value here. And so we can see that, home price field contains number field. We got a new import for that number field. Perfect. So in addition to home price, there's going to be a whole bunch of other key information, right? Because the home price by itself doesn't define your how much you're going to pay per month. As we saw, it's going to depend on what your interest rate is, your down payment. So let's start to capture those. We just added a field using the schema editor. I'm going to add a field in a different way, which is using a programmer's favorite tool. You know what that is, Chris?
Control V, Control V.
Very good. Also known as copy paste, or depending on who you're talking to, sometimes copy pasta. So this is down, call this one down payment percentage. So the user will enter that they're going to put 15% down or 20% down. Next one we'll say is how long is this loan? And I'll just add years to the field name just so it's very clear that what kind of units we're dealing in here. And In addition to that, we of course need to know the interest rate. And we'll expect this to be expressed as a percentage.
Mm-hmm.
So, 7.5 or something like this.
Mm-hmm.
Now, in addition to those are sort of the core pieces of information, but I noticed on that mock that you showed, there's other monthly payments that are unavoidable if you are going to own a home. And so we want to capture those as well so that people can get a sense, people who are using this can get a sense of, oh yeah, but what do I really need to be able to spend per month if I'm going to acquire this?
Yeah, and the mortgage bank can look at those as factors as well to make sure that you're like not ignoring the cost.
Exactly.
As they always say, like mortgage is the minimum you're gonna pay, a rent is the maximum you're gonna pay. You gotta include these extra thrills.
Yep. So here we've got taxes, property taxes. We have homeowners insurance. Most mortgages require that you carry this, so not negotiable. And then, of course, depending on where you're buying, there's everybody's favorite kinds of fees, HOA fees or condo fees, or whatever you call it. But it's things that you have to pay to keep up the common space.
It's kind of like paying protection for protection.
Yeah, that could be a separate field and a different kind of mortgage tax.
Yes.
Depends on the neighborhood, I guess. Cool. So we've got a few fields. Let's go ahead and create a card instance and just see, is what we've done so far working. Mm-hmm. So I'm going to use this create instance button here on the left, and we'll create a new instance in this drafts workspace. Things are spinning, and okay, lo and behold, I've got my edit view here with all these fields that we just added. Looks pretty, straightforward here. Mm-hmm. Let's put in a few values. So I was looking at this condo in Miami.
Nice.
Not too expensive, oceanfront, $395,000.
Wow, it's a steal.
It's not cheap, but so let's go and we'll put that in as our home price, 395,000. We'll put some kind of straightforward typical values. 20% down is pretty typical. 30-year fixed rate mortgage is the most popular mortgage in America, I think. Mm-hmm. What are we at? About 7.4 these days?
7, 8.
Yeah, we'll try that 7.4 for now. Taxes per month. Quick Google, Florida property tax rate 0.98%. So let's do 395,000 times 0.0098 divided by 12, about $320 a month. Put that in. And insurance, I'm sure this varies. My insurance is about $50 a month, so let's just put it there.
Yeah, but you're in the ocean, you may have to do like flood insurance or something. I don't know. But this condo is fine, you're way up.
Exactly.
Not your problem.
It's just to the people on the low floors. And then HOA fee per month, the advertisement for this particular property said that it was about $750 a month. Cool. And then we've got some of our, of course, the fields that come with the base card definition. And we can ignore those for now. We may want to use them later to maybe label each of our different cards, but those are there for now. So if I flip over to isolated mode, okay, I see the values that I entered in edit mode. So far, nothing too exciting because, of course, we need to do the calculator part.
Right.
So what we're going to introduce for this part of the card is a new feature that we haven't seen so far as we've been working with our cards, and that is called computed fields. So let me show you what a computed field looks like. And let's, I guess, think about what is the first computed field we need to make. So we look at this one. This has the principal, month, the rate, and the number of payments. So the rate is pretty straightforward. We have that already. Number of payments, we'll need to do a little bit of math to get that. And the principal, we'll also need to do some math because we know the home price and the down payment percentage, but we need to do a little math to figure out how much do you actually need your loan for. So let's try to figure that part out first. The first step is going to be, what's the down payment? So I know my percentage, I know my home price. This is very straightforward math. I'm going to say that this is my down payment, and it contains number field. And to make one of these fields computed, what we're going to do is we're going to say comma, and then a little options array here. We say compute via, and I'm going to tell it that my this is an instance of this mortgage calculator card. Whoops. Just grab the class name by itself. This is a TypeScript-ism right here. So people are familiar with TypeScript will understand what this means. If you are a JavaScript developer but haven't used a lot of TypeScript, what this particular feature does is it helps TypeScript understand what is this going to be when the contents of this function executes. And that's important because we want to be able to check our types as we refer to other fields. Because of course, for a computed thing, what are you going to compute? You're going to compute values of other fields into some new value.
Right.
Awesome. So now comes the fun part, which is the actual calculation.
Hey, I saw that there's an equal sign that just showed up next to the field in the schema editor.
Oh yeah, look at that right here. So this is giving us a little cue that this down payment is a computed field. You can actually see the word computed right here appears underneath as well. So schema editor will recognize that you have a computed field and reflect it for you. It doesn't allow you to enter value, enter your formula in there. And there's, I think, some good reasons for that. When we're in this formula entering part, we're really dealing with JavaScript, and there's no better way to deal with JavaScript than in an editor where you're actually writing the JavaScript.
Exactly.
So, okay, what do we think the formula for down payment is here? Let's see. We've got the home price, and we're going to multiply that by our down payment percentage, which is going to be this dot down payment percentage and divided by 100, right? Since it's a percentage, you have to divide by 100 to make it the value that you're going to multiply by. Okay, so in theory, this will work. Let's flip back to our card and take a look at what we see here. So let's see. Nope. It took a minute because the change that I made was being indexed by our Boxel host server. But now that it has, we can see that 395,000, 20% down, it says it's 79,000. I'm going to check the math using my handy dandy little calculator here. We'll say this times 0.2, 20%, and lo and behold, Boxel is right. It's 79,000 for the down payment. All right, so good news. Computeds work. We're going to create a whole bunch of them now in order to get to the point that we need to do all this stuff. So the next value that we're going to create is we know our home price, we know our down payment. What's the amount that we need for our loan? That's going to be the difference between those two. So this is going to be the loan amount. And I'll just grab some of this boilerplate right here. Copy paste, programmer's best friend. We're going to say this dot home price minus this dot down payment. So Chris, you know what this reminds me of?
What is it?
It kind of reminds me of like working with Excel, like doing formulas in Excel.
Yeah.
What do you was that something that you had in mind when you designed this part of Boxel?
Yeah, I think Excel is really good because you can look at the data and then react to them and say, okay, is this number in this cell minus this number? And you can select them. And right now in the code editor, you don't actually show the value, but you do show the field name, right? So that's the completion in the TypeScript that is in this editor, which is based on the open source Monaco editor. I think we have some plans so that the same mechanism could be for the people who don't read code, or they can actually look at the data and say, I want this minus that. But it's the same thing. It bottoms out to writing JavaScript, which I think is actually pretty cool, right? Because Excel with Microsoft and Google spreadsheet, they give you a pretty wide array of formula, but it's pretty limited. Here, you can tap into almost any calculation that you can do in JavaScript and use any modules. And again, we have to bundle them in and clear them for security reasons. But it's an ever-growing catalog. And if we can use JavaScript's kind of logic, but have this kind of what we call functional reactive, as you type something, it updates. You can emulate most of the things you can do in Excel in this card type of application.
Yeah, very cool. All right, so let's continue on. In addition to the loan amount, we saw that for that formula, we're going to need the number of payments that you're making in the loan as well. And my browser's become non-responsive. I'm going to give it a refresh here. It's a good opportunity to remind folks at home, Chris, that this is pre-release software.
Right.
So definitely working through the bugs.
We should wear hard hats when we do this thing, just to be very clear.
Yeah, there you go. So in addition to loan amount, I said we're going to need the number of payments. And that is going to be the loan term in years times 12, because it's 12 payments per year. I think that in order to calculate this effectively, we want to get the monthly mortgage rate. So that's going to be our interest rate divided by 12 to give us how much the interest is actually per month, because that interest rate is expressed in terms of a year. So it's going to call this monthly interest rate. This is going to be our interest rate percentage divided by 12. And we'll divide it by 100, so we get the value that's math ready.
Right.
The percentage value that's math ready. And now that we have these kind of core pieces, we're ready to actually do this formula, the granddaddy, to really calculate the monthly interest rate. So we're going to call this, monthly mortgage payment. And it's going to be computed like these. And the value is going to be principal, which is this dot loan amount, times the monthly interest rate. Flip over back to here. Principal, yep, okay, good. Monthly interest rate times, let's see, it was 1 plus the monthly interest rate. And then we're going to bring all of that to the power. Math.pow is how you do exponents in JavaScript. We said that then we're bringing it to the power of the number of payments, which is this dot number of payments. And then we're going to divide this. But before I do, we're getting a little cramped here. So I'm just going to adjust my column widths a bit to give me a little bit more space. And I'm going to start to format this code a little bit to also give me a little bit more space as well. So this is the top of that kind of fraction that we saw. Let's make sure that our parentheses match. Looks pretty good. So then we're going to say that it's this divided by, and the bottom is 1 plus r10 minus 1. So the math pow is the same. I'm going to grab that here. Minus 1, and make sure we're going to protect our order of operations, right? Otherwise, PEMDAS is going to get you an acronym for order of operations that you learn in school.
Pay attention in math class.
Yeah. All right. So if I did this right, then our calculator should work. Let's see what happens. Fingers crossed. Hey, we've got something happening. So we can see all of these computed that we added, and we can see a monthly mortgage payment of $2187.92. And that does seem about right.
Yeah, seems about right.
For that kind of that house price. Now, we of course have a few issues here. One is I can always go over to edit mode, and I can tweak some values, like maybe I only want to put 15% down.
Right.
And we can see things in real-time update. So my monthly payment just went up to $23.24.
Right. As you expect.
Yeah, exactly.
More.
This is cool, but we talked last episode about how the isolated view of the card is the main one that's displayed when you're looking at a full card.
Yeah, when you open it up in the index, right? Like treat them as like a file that you open up, you see the isolated view.
Exactly. So the problem that I have with what we're looking at is that I don't want a user to have to move to the edit view in order to use the calculator. That's kind of silly. So what I think I want to do is I want to replace this default isolated view here with a custom template so that we can make this look the way that we want it to and have the interaction pattern be the way that we want it to. I thought the mock that you showed was very attractive, and we should try to do something like that.
Sounds good.
Cool. So let's go back here. Now we have, if we scroll down to the bottom of this card definition, when we created it, when Boxel created this for us, we have this handy little commented out area that shows you what you should do if you want to define your own isolated template. This was an addition from to the system from last week when we did it, last episode, because remembering all this boilerplate is kind of annoying, and so it's nice just to have it.
Little programmer's aid, little instruction printed on the bottom of something.
Yeah, we think about DX a lot at CardStack.
Developer
DX
experience.
For developer experience, exactly.
Exactly.
It makes a difference. All right, cool. So let's go ahead and start to put some values in here. I'm not going to talk a lot during this part because so that you can speed me up. Last episode where we used @fields.bio for our markdown field. And the reason that we did it is because we wanted to get the fields built-in display logic, right, to work for us. So this time I want to dive a little bit more in depth into what's happening here. So what's happening with @fields dot is that this gives us a component. And in our templating language, we talked about how using the double curly braces shows you the value of a variable. Well, using the angle brackets here around a component reference, like so, invokes that component. So it basically renders the component in this place, this spot. Now, the component for a number field in isolated mode, there's not much to it. It just literally outputs the number.
Pretty much just print the number, right?
Yeah. So there's no real difference normally in isolated mode between @fields.homePrice and @model.homePrice.
Right.
In both cases, you get the value. However, in our case, we want to do something a little bit different. We want some of these fields to be editable in this view. And so what I'm going to do first is to go and look at our current isolated mode. So what I want to point out here is that here in our isolated view, we're now outputting the home price as 395,000. But I want this to be an editable field. And the really cool thing about using this @fields.homePrice is that it accepts an option here. I can say @format equals edit. And this tells it to use the edit view of its field. And now, when I said before that the isolated view rendering of the field is simple, it's just a number, well, the edit view is a significant amount more complex. It's actually a field that you can make changes to. Yep, here we go. We've got a field I can enter. I can change a value. I can type something that's not a number, and it doesn't let me. It says input must be a valid number here. And just to show that this really is working, if I say, let's say 495,000, and I flip over to edit mode, we can see that that's reflected here. And if I refresh my browser, we can see that that value has been persisted on the server. So
is that the same field as the field that is in the edit view?
It is indeed. Yep, it's the same way that the edit view renders this. We've just instructed the isolated view. We'd like to use that format here as well. But what's, to me, one of the things that's pretty amazing about this is that here in my isolated view, with literally just adding format edit, I have validation, persistence, input capture. I didn't have to write any event handlers. I didn't have to write any API calls or code. I didn't have to write any form HTML, right? We we noticed that the field turned red when I had a non-numeric value in. All of that comes baked in for me just by changing that format, it's pretty powerful stuff.
Yeah, because it allows us to say when you want a certain field, a certain behavior with certain validation, if you choose the right field and you use it in your edit form and then you use it in an isolated form, all of the validation and logic and rules and formatting comes with it if you delegate to it. Now, you can always say, no, I want to be fancy. I want to override everything and write my own template. You're welcome to do that. But by picking a format, you're basically saying, I want to control the way this is set up and kind of the layout, but when it gets to the nitty-gritty bit, I want to kind of treat it like a YouTube player embed code where you don't want to deal with like playback and caption. It's like, okay, I have this beautiful web page, stick the YouTube player there and use these features. And that's exactly what's going on. Each field is an entire embeddable application within your application.
Exactly. The it reminds me of a saying that we have in some programming languages, other things too. I guess turtles all the way down. Have you heard this before?
Turtles all the way down. Yeah.
It's really cute. But I think it's pretty compelling. And there's tons of this behavior in Boxel where the building blocks for everything that we see here are the same, or the same building blocks that make it up. And so cards can be combined with cards, can be combined with cards, can be combined with cards to create really, really powerful capabilities.
Right.
Cool. Okay, so I'm going to use some clipboard values to jump us forward a little bit, so you don't have to watch myself typing too much. And let's add some results fields as well. So to start with, the key result that I want is the monthly mortgage payment, since that's really the key value. So we'll start by just doing the same thing, fields dot monthly mortgage payment. And let's go and take a look at our instance, see how we're doing. Okay, so we've now got this in our isolated view. We've got our fields, and we can put it back to 395, put our down payment to 20, and we can see that our unlabeled currently monthly mortgage payment is 2187, which is correct. Now, there's one massive problem with this. Actually, there's a few massive problems with it. One is it's generally ugly. Two is it's flush left against the edge of this card. And the third thing is it's supposed to be a dollar value, but it looks like some sort of scientific number. Right. So let's solve the cramped up against the edge part first, because that's pretty easy. And then we'll come back and we'll fix that formatting. So for the crimped back up against the edge part, we're just going to add a little bit of style. Now, if you remember from last episode, we have the ability to add automatic scoped styles by just adding a style tag to our template. And what I'm going to say is that for our wrapper class, we're going to have padding. It's going to be, I think it's about 16 pixels. Should do it all around. Let's take a quick look. Okay, I can breathe.
You can breathe, yeah.
Yes. Okay, so the next part is pretty fun because we get to learn another new concept in Boxel. And that concept is called helpers. And so what it lets us do is it lets us have a JavaScript function that's going to transform some value in our template. So here we have fields.monthly mortgage payment. And if you remember before I said that this was a component, we want to get to the underlying value so that we can transform that value. So as we did in the Hello World version, we're going to say @model dot monthly mortgage payment. And this is going to give us back a little number, and we're going to put it in curly braces instead of these angle brackets because it's no longer a component. So this is going to output the exact same thing. I can prove it by jumping back here. Everything looks the same. So now what we want to do is we want to transform it by passing it through a function.
But now you're owning the display layout. The isolate template is like, I'm taking ownership of what is displayed. I just want the data.
Exactly. And the isolated ownership has total flexibility. We can do anything we want with HTML, CSS, our templating language, and leveraging the raw data of the card or leveraging those components that the card's providing us that we talked about. So I'm going to define a JavaScript function up here, function declaration. Let's call this format USD, and we'll have a value in here. In order to format this value, we can use some built-in capabilities of the browser. I'm going to grab those from here and paste them. So what I'm doing here is I'm using a built-in browser API called INTL, short for internationalization. And it lets me look up a number format for a particular geography and language combo. So in this case, it's English, US. It's saying I'm able to say that I want this number format to be in the style of currency, and the currency is USD. And then what I can do is I can say in the body of this template, I can say I want to return formatter.format parentheses value. Now that I have defined this function, I'm going to go back down to our monthly mortgage payment. I'm going to say format USD. So this is the function name. It's available because the function is defined here. So for those programmers in the audience, this is called lexical scoping. Basically what it means is that because this is defined in an outer nested area to where this template is, the stuff that's in these inner areas can see what's defined in the outer areas. So let's go back to our layout, and wow, check it out. We have a formatted monthly payment. So I want to point out a couple of cool things that I think are cool about this. The first thing is we are heavily leveraging browser technology here, right? The ecosystem of the web and of web browsers has come so far in the last 20 plus years. And Boxel is really an environment that is of the web, from the web, embraces the web full on. And so that's really cool to be able to get that kind of power without even having to use a library, right?
Yeah, and also if you change your browser setting or the operating system, there's a communication between your browser and operating system that just works, right? Because it's if you're in a different region with your OS, that's being communicated with a browser, and the browser by way of that INTL function, is that INTL?
Yeah, INTL.
Like projects it into your application.
Yep, very cool stuff. The other thing that I want to point out is that the reason that we could have written this function like this, had the const inside the function declaration. And so every time you run the function, you create a new number formatter with these properties and then call formatter.format. But I know we're going to use this format function a bunch of times. And by defining this formatter object outside, we're going to be able to let the browser be a lot more efficient with it. It's able to reuse that formatter instead of having to instantiate it, garbage collected, instantiate it, garbage collected. So, minor stuff could fall into the category of premature optimization, perhaps, but I think it's fun to do things right. So awesome. So now that we know that we can format the data correctly and that we have the monthly payment coming out correctly, I'm going to add a bunch of the other results field to our output template, and then we'll try to make it look good from there. So I'm going to go and get those from my clipboard. Okay. So we've now got a bunch of output. It looks a little bit like the template that we made. Let's go take a quick peek at how our isolated view is looking. Looks. I'm gonna confess to you, Chris. I expected to see more here.
Yes. Oh, it's showed up.
Oh wow. Okay. Again, I'm just being a little impatient. So again, that indexing process that runs is. We have to wait for it currently. We have plans to move that particular indexing process when you're in code mode. We're going to move that in memory into the browser. Almost everything that we've written in this area of code is what we call isomorphic JavaScript, or TypeScript in this case. It means it can run on the server and run on the client. So it gives us a lot of flexibility in terms of kind of where and how we deploy our resources.
Yeah, the first version run entirely in a browser, and then we wanted to do the hosting thing so people can see the thing that you have created. We run on a server, and now we're seeing some of those client-side runtime capability being especially for programmers, a really nice feedback loop.
Yeah, we want to be able to have in code mode, as you make changes, to see those values updated, everything updated in real time, give you real-time feedback. And we think that the best way to do that is probably to bring it into the browser. So in any event, we see some NANs here. Do you know what NAN stands for?
Not a number.
That's right. So it's a JavaScriptism. One of the weirder aspects of JavaScript, and I have to say that this little NAN thing can pop up in your programs, but it's important because when you try to deal with something as a number and it's not, well, sometimes the only thing the computer can do is say, it's not a number. And that's what we have here. And so the reason for that is because in the template, I dropped in some computeds that we haven't added yet. So those are the lifetime values, because in the template the mock that you showed us at the beginning, it has not only the monthly values calculated, but it also calculates the lifetime values over the length of the loan. So how much interest and principal that I actually paid, you actually pay in the end, can be a scary number, but it's a number it's good to know. So I'm going to go ahead and grab those fields and drop them in here, along with the field that totals up everything that I'm going to spend in a single month here, monthly total. So I've got my lifetime mortgage payments, lifetime taxes, lifetime insurance, lifetime HOA fees, and then a total for the lifetime. And so if I flip back, now most of my not a numbers are gone. Looks like I still have a HOA fees as a not a number there. So we should take a look at what's going on there. We can see we now no longer have any not a numbers. We can see scarily that over the lifetime of my mortgage, if I pay $750 a month to the HOA, I'm going to have spent $270,000 to my HOA. Wow. And
there's a lot of monthly mixers to play.
Sure is. I mean,
they better be
I like clean sidewalks, but
caviar, right?
And we can also see that the total out of pocket per month between our taxes, our insurance, our HOA fees, and our mortgage payment is $3,300. Over the course of the loan, it's going to be $788,000. That's pretty amazing, considering if you remember the price of the house the apartment condo is only $395,000.
That's true.
So, but anyway, we're not here to comment on real estate exactly.
Right.
Really, we're here to make cards, and this card is, while it's functional, is supremely unattractive. So let's bring some CSS in. What do you say?
I think it's always a good trick, right? Decorate, like painting the house, like decorating, it's all about the finishing, right?
Yes, indeed.
In the condo.
So I'm going to go and grab some of our CSS to drop in here. So remember, we didn't change anything except for CSS just now. Let's see how things are looking. We have some persistence still happening. Got a spinner. There we go. I was about to say that I'm not that patient, but I was patient enough to wait. All right, so this is looking pretty
nice.
Pretty good. Much easier to read. Let's tweak it a little bit, shall we? What if we did a 15-year mortgage instead of 30? Okay, so we went from our total out-of-pocket expenses being when it was 30 was 3.3 a month, $3,300 a month. And when it's 15, oh, you know what? I lost my HOA fees again. Very interesting. Yeah, so about the difference of about 3,300 to 4,000 in terms of out-of-pocket expenses.
Seems about right.
Yeah. So this is super useful to to get an idea and be able to tweak and play. The mock that you showed in the beginning of the episode here had a little visual element that I thought was really nice. They had a little chart showing kind of how your monthly expenses break down.
Yeah, it's like a pie chart for like the proportion of what you're paying per month. Where's it going?
Yeah. It was a pie chart, but it had no middle, I noticed.
It's a donut chart, I think.
You got a donut chart. So it just so happens, Chris, that I have the code for a donut chart component.
Nice.
Now, so far we've talked about cards and we've talked about fields. We haven't really talked, and we've talked about components in that context, but you can also use components standalone just to enrich your cards. And that's what we're going to see how to do today, or at this point. So here's my donut chart component. I'm going to first grab this import statement and I'm going to pop that at the top. So the type of component that we're creating is called a Glimmer component. And Glimmer is the component and templating engine that powers a JavaScript framework called Ember, which we're big fans of at Cardstack. And we're going to grab the implementation of this. And we'll take a look so we can see how it works. I'm going to paste this. I'll paste it just below our format USD helper before our class implementation. So this is the main donut component. We can see that it inherits from Glimmer component. And we can see that if we look down at the template, it's outputting some SVG code. And SVGs are great for making charts and stuff.
Vector graphics, yeah.
Yeah, they scale beautifully. They're designed really well to size and style with math, and which obviously is important when we're doing this kind of thing. And so this is a TypeScript-aware component, and we can see that the signature for this defines the particular types of values that we're allowed to pass into our donut chart. And we can see that it's going to take two elements here, two arguments, data and size. The size is pretty straightforward. So it's going to be the size in pixels that we want this donut chart to be. Data is defined as an array of donut section data. And donut section data has three things: an optional class, a color, and a value. Makes a lot of sense as you think about what we're trying to do. So our job is going to be get the values from our business domain into this donut chart according to the interface that it just expressed that it would like them in.
Right.
And I've got that code here. I'm going to grab it and we'll walk through it together. So inside of our isolated template, above the template declaration, we haven't actually seen anything so far in our format components besides template code, but it turns out they're quite full-featured, and you can put TypeScript, JavaScript in there too. And so what I'm doing here is I'm defining a chart data property. I'm grabbing the model from our args. This is the same as @model that we access in the template. The reason that I want the model class is because I want to be able to get the values out of it to kind of massage into the format that this donut chart component expects. So I'm going to return an array, square brackets, of value of a donut, what was it called? Donut section data, I think it was.
Right.
Each one we said has to have a value and a color. And I'm going to throw in a few other things that will come in handy later, a label and a percent. So the colors I'm just making up to be attractive here. The values I'm getting from our model: monthly mortgage payment, tax per month, insurance per month. These will look familiar to you all because these are the same values we used in our template. And then I'm going to take this and down here towards the bottom of our component, I'm going to say donut chart at data equals this dot chart data. That was the property I just defined that we just walked through above. And I'll say at size equals, let's say 160. And then I'll need to close that element. And let's go and take a look and see. Wow, okay, well, this
That's a
is
thing.
not in the location that I anticipated, but it does look like it has the right breakdown, assuming that green is our mortgage payment. This is probably our taxes, HOA fees, and home insurance. So let's get this in the right place, and I think we would need a legend here as well.
You don't know what it is because I don't remember the color.
Exactly. Color is kind of arbitrary.
I can't read hex.
One day, keep trying, Padawan. So here's some HTML for a legend, and let's go and back to our definition, to our template underneath our chart. Let's put a div around this. Call this chart. And our legend is going to go here. So let's look at what's happening here. We're using a slightly advanced feature of our templating language to get this done. It's called pound each, and it lets you iterate over arrayed data. And so iteration and looping, if you will, is a core part of every programming language, every templating language. And so we're taking advantage of that feature that's built into handlebars, our templating language that we're using here.
So this will be in lieu of like the type of JavaScript for loops or while loops?
Yeah, it's sort of like, handlebars is a language, or it's our templating language. And so if we were iterating over chart data in JavaScript, then we would say exactly for in or something like that. But because we're iterating over it in handlebars, we're going to have to use the native handlebars way to do that. And that way is pound each. And then it has this little thing called as, and then you give between these pipes, you give it a name. What do I want to call each instance as I loop through? We'll call it item. So we're going to take the item.color and we're going to output it here inside of this style tag in order to set the background color of a swatch. So we're going to imagining like a little swatch of color like legends have, right? And then next to that, we will output the percent from the item and then the label. And if you remember, these were items that I defined in chart data before as we were looking through for just this purpose.
So you're reusing the information data structure you're passing a chat component and using that same thing here.
Exactly.
Nice.
Same thing goes into the chart and into this legend. Got to close my chart div. So if we close that, if that works, then we should see the schema editor come back, and we do, and we flip back over to here, and
nice.
Boom, I've got a legend. Not quite in the place that I intended it, but it is outputting there. And so I'm going to take a quick look at my notes here to see if I can tell why. Div class, oh yeah, okay. It's supposed to be a sibling to our chart, not nested in that div in order for the CSS to work right. So if I come back to the bottom of our template, I grab this legend here, and now we jump back. Beautiful.
Great.
So now we didn't go through the CSS in detail, but just for anybody who's curious, we're making heavy use of CSS grids here. Really compelling feature that's been added to CSS over the past few years. It lets us kind of lay stuff out in a nice grid format. You can almost imagine like a line going here and a bunch of vertical lines dividing these sections of the grid, and then we're able to kind of place each element in the right cell of the grid. So
Yeah, when you turn on the grid line, it will look like Excel.
yeah, exactly. Funnily enough, and so this is all open source. We're adding each of the code from each of these episodes into our open source repository.
Yeah, so you can see
if
how
you're
it's
curious
done,
about it, yeah, you can go and look at that CSS yourself as well. But I think that kind of brings us to the end of what we needed to do here. We've got a calculator that looks pretty great. Works pretty great. I guess one thing I'd love to do is to just take a quick look at it in our interact mode.
Right.
Let's see if we can take a look there. So here's our mortgage calculator card. And if we click into it, you can see in this interact mode, it sort of stacks these cards up. And sure enough, without any of the code mode stuff, it's here and it still works. It's pretty neat.
Very cool.
All right, this was fun, Chris. We should do this again.
Absolutely. I think what's really cool about this is that when you look at the interact mode, like this is an app, right? Like if you make a new version of it, you can type in new data, and that's a new kind of in scenario. So if you're like shopping for multiple houses and different types of percentage and stuff like that, you can use the same underlying mortgage calculator card as an application, and then create different instances of it that allows you to save them. You can compare them like as if they're like images. So you don't have to go to a website and take a screenshot and compare them on your phone. You can actually have the live data and see how it works.
Yeah, and that gets, when you're dealing with even more intricate data than this kind of calculator, that becomes even more and more important, and unleashes a lot of power.
Yeah.
Yeah, so that's great. So one thing I would encourage, if it's okay, Chris, I would love to invite viewers to, if you have questions about any of this stuff, feel free to leave comments on the YouTube video. I'll check them out and I'm happy to answer them. And yeah, look forward to doing this again soon.
Absolutely. So I think as part of this Card Maker series, our goal is to essentially dog food this platform and this idea and try different use cases. You know, we look at CardStack and especially the Boxel product as a unified operating environment for users, much like if you use an operating system, like in a traditional Mac, Android, iOS sense, where you learn the tools of the OS and then you can do many things within that same tool. The tools are consistent, how you create things, how you swipe, how do you open an app, how you close an app. And we want to have a set of principles here that is the user can understand, and that's going on in the interact mode. It's part of our operator mode. The code mode we're showing right now, I think most users will never see that. But the cool thing about it is that within the same environment, we're providing developers the tools that's very, very, very close to the user. Like you're like one flip away on the switch to be able to have that stuff. And if you have libraries and code, you just paste it into it and that's deployed. It's part of the runtime, it's part of the indexer. It's really wild. And it's kind of the original computer science-y dreams of like hypercards or different types of like operating system working kind of in conjunction with the users and programmers are working together. And that's our own version of it. And I think the web platform, as Luke points out, is a really important part of it. This is a web application. This is no different than what you Google like mortgage calculator, except it's your data, your code, open source, nobody's sticking any cookies in it. This is just a way to visualize the world and use software as it's been written and shared in the context of everyday lives.
Yeah, and I would say that, you know, you were just explaining that most users might never use code mode, but I think it's important to point out that developers are a really important part of what will become the Boxel ecosystem.
Absolutely.
There's so many really cool opportunities to create a new world of software here. It's going to require an army of developers to embrace and participate in this ecosystem, and so that's one of the reasons why we put so much attention and care into code mode, because we want to really help those folks get on board when it's time and understand it and have good tools to work with.
Absolutely. And in a future episode, we'll talk about how you can share this code, how you can reuse other people's code. But right now, kind of using the substrate, the computational substrate of the card, I hope we've shown that we go beyond the CMS, the landing page and About Us page on a beach volleyball thing into a mortgage calculator. And hopefully we will take the next step and do something more database in the next episode. So until next time, take care. there. And Luke, thank you so much.
Yeah, I'll be at my Miami condo hanging on the beach.
Sounds good. Let's
Ciao.
all hang out then and have a martini. Great. See you all soon.